solve for x. Here I have log of x plus 2 minus log of 4x plus 3 equal to the log of 1 over x. What I notice is that on the left-hand side of this equation, I can rewrite this difference. If we have the difference of logarithms, as long as they have the same base, I can rewrite it as the ratio of the arguments. So here, I can rewrite the left-hand side as log of x plus 2 over 4x plus 3. And on the right-hand side, I have log of 1 over x. Now, since both logarithms don't have a specific base, I am under the assumption that we are dealing with base 10. And if we have the same base, that means that the arguments are equal to each other. So I'm going to set up x plus 2 over 4x plus 3 equal to 1 over x. I have a proportion, and whenever I have a proportion, I can cross multiply. So first, I'm going to multiply the x with x plus 2. So I get x multiplied with quantity x plus 2. And on the right-hand side, I'm going to multiply the 1 with the 4x plus 3. I'm going to continue to simplify this. X, I have to distribute it to both terms, so x times x gives me x squared, and then x times 2 gives me a positive 2x. On the right-hand side, the 1 is not going to change the outcome of that expression, so I'm still left with 4x plus 3. I notice that I have a quadratic here on the left, and I also have an x term. So my objective now is going to be to collect all x's and then move the coefficient to with the x squared and the x to form a trinomial. So I have x squared, and if I subtract 4x from both sides, I'm going to get a negative 2x. And now I'm going to move this 3 to the left-hand side to create a trinomial. So if I subtract 3 from both sides, I'm going to be left with x squared minus 2x minus 3 equal to 0. And this is a quadratic equation. My leading coefficient is 1, so I can try to use this x method and see if this is factorable. If I can't factor this, then I'm going to use the quadratic formula. But right now, I need to try to find two numbers that are going to multiply to negative 3. But at the same time, those two numbers are going to add to negative 2. And the two numbers that satisfy these two conditions are going to be negative 3 and positive 1. Negative 3 times 1 is negative 3, but negative 3 plus 1 is negative 2. So I can factor this as x minus 3 and x plus 1. That's going to equal to 0. It's at this point that I can use the zero product property, which tells me that if I have the product of two things and that product is equal to 0, then one of those things had to be 0 to begin with. So x minus 3 equals 0, x plus 1 equals 0. I solve both equations. I add 3 to both sides for the first one, and my first solution is x equal to 3. For the second problem, I'm going to subtract 1 from both sides, and 0 minus 1 is negative 1, so my second solution is x equal to negative 1. Well, these are the candidates because remember, these two solutions, they have to produce a positive argument on the original equation. But you can see that negative 1 is going to produce a negative argument here, since 1 divided by negative 1 is negative. It's also going to produce a negative argument here, since 4 times negative 1 is negative 4, and then if we add 3, we're going to get a negative 1. So negative 1 is not going to be a solution to this equation, so we're going to disregard it. And we're going to check 3, positive 3. So if we put in a positive 3, we're going to get a positive quantity, so the 3 checks out. Here we're going to get 5, here we're going to get 16, and then here we're going to get 1/3. All of those quantities are positive, so we are good. So my solution to this equation is x equal to 3.